let's do some solve for x with radical functions, but we're going to check for bogus solutions. Let's get this show on the road. So first things first, I've got a radical on one side, and I don't have a radical on the other side. But fortunately, I'm still going to use my strategy of squaring both sides, because I want to get rid of that radical. So I've got x minus 2 is equal to the square root of 4x minus 12, but I'm going to square both sides because I still want to solve for x. Okay, so if I square both sides, all that means is that it's x minus 2 times x minus 2, okay? And the square cancels out the square root, leaving me with just 4x minus 12. Okay, so now that we've established that the right side is 4x minus 12, we might as well FOIL the left side. So we've got x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Therefore, the right side is still 4x minus 12. And I'm just going to combine like terms on the left side. So I've got negative 2x and negative 2x. That forms x squared minus 4x plus 4 is equal to 4x minus 12. So now I've got to solve for x. Well, we got to use our old buddy factoring quadratic trinomials. So the trick is to get everything on one side where it's x squared minus plus or minus bx and plus or minus c. So I'm just going to get rid of everything on the right side and move it to the left. So that I'm going to subtract 4x and add 12 to both sides. So now I'm going to cancel out 4x minus 4x, negative 12 plus 12, and that leaves me with x squared minus 8x plus 16 is equal to 0. So now let's check our work. If I look at this, now I got to figure out how to factor x squared minus 8x plus 16. And what that needs is what multiplies to positive 16 and adds to negative 8. Go back to that strategy. So if you can figure out that winning combination, all right. It has to be a negative-negative combination, so negative 1, negative 16 doesn't work. Negative 2, negative 8. That doesn't work. Negative 4, negative 4. Ding, ding. So that checks out. Therefore, this factors into x minus 4 times x minus 4 is equal to 0, or x minus 4 quantity squared. Either way, there's only one solution. We just bring that down and we say x minus 4 equals 0. Solve for x by adding 4 to both sides. Therefore, the only solution to this problem is if x equals 4. But look at the directions. Check for any extraneous solutions. In other words, you did everything right. But if x equals 4 gives you a false statement, then it's no solution. So I'm going to plug it back in. So remember, my original equation is x minus 2 is equal to the square root of 4x minus 12. So now I'm going to check x equals 4 into the equation. So let's start with the left side since that makes life easy for me. So I've got 4 minus 2, which is 2. I've got 4 times 4, which is 16, minus 12. So I've got 2 is equal to the square root of 4. And the square root of 4 is in fact 2 because we're counting the positive root. Sorry about that. So 2 is equal to 2, so that checks out. So therefore, the only solution to this problem is, in fact, x equals 4. It works. Okay. Turn the page. Now, this one's a little bit different. The square root of negative 48 plus 14x is equal to x. And I want to solve for x and check for any bogus solutions. All right, here we go. So if I look at this, I want to solve for x, but in order to work with it, I need to undo that radical. So I'm going to square both sides. Let me get my green. So if I square both sides, the square and the square root cancel out, leaving me with just negative 48 plus 14x is equal to x squared. Okay, so now this is kind of annoying unless I get everything to one side. Personally, I'm going to move everything to the right side since that a equals 1 on the x squared makes my life so much easier. So I'm just going to recopy this and add 48 and subtract 14x to both sides. So minus 14x plus 48 on both sides. Let me just, so nobody thinks it's a division sign. So that's really all I'm doing. That cancels out, that cancels out, that cancels out, that cancels out. So now I'm left with 0 equals x squared minus 14x plus 48. Okay. Now then, here comes the fun part. I got to factor because factoring is an essential skill. What two numbers multiply to positive 48 and add to negative 14? If you can figure out that winning team, awesome. All right, let's try it. Well, it has to be two numbers that multiply to a positive and add to a negative, so it has to be a negative-negative combination. So let me try negative 1 and negative 48. They add to negative 49. I'm going to get a different multicolored pen since that black ink seems to be leaking everywhere, leaving little blotches. Let me try negative 2. That's much better. Negative 2 and negative 24. Negative 3, negative 16, negative 4, negative 12. Nope. Okay. Getting warmer though. Negative 5 doesn't go in there without a decimal. Let me try negative 6, negative 8. There we go. That's the winner. So since that's the winning team, I'm going to factor x squared minus 14x plus 48 into x minus 6, x minus 8. And you can use the zero product principle to break this down into two equations. So now we've got x minus 6 is equal to 0, or x minus 8 equals 0. And now we just solve for x. Where x is equal to 6 or x is equal to 8. But remember, oh, the directions aren't up there. Check for any bogus solutions. You did everything right. And if I plug in x equals 6 or x equals 8, who knows? It might not even be a true statement. So let's plug it back into the original equation. The square root of negative 48 plus 14x is equal to x. Okay, so now I'm going to check on the left side, x equals 6. Okay, I apologize. I don't know my 14 times tables. 14 times 6 is 84. So I've got the square root of negative 48 plus 84 is equal to 6. Let's hope this is right. 84 minus 48 is 36. So the left side is the square root of 36 is equal to 6. The square root of 36, since we're counting the positive square root, is in fact 6. We win. So x equals 6 is a solution. Let's check to see if x equals 8 is a solution. So now I'm going to plug in negative 48 plus 14 times 8 is equal to 8. Now 14 times 8, 112. So negative 48 plus 112 in the radical should be equal to 8. 112 minus 48 is Nintendo 64. The square root of 64 is equal to 8. Is that a true statement? Yeah, since we're counting the positive square root, that works. That works. So therefore, x equals 6 or x equals 8 are both valid. Okay, 4 more. Okay. The square root of x minus 1 is equal to x minus 3. See if you can do this problem independently. Okay, pause the video if you need time. Okay, so now the square root of x minus 1 is equal to x minus 3, and I'm going to get rid of that radical because it's annoying me. So now the radical getting squared, those two cancel each other out, leaving me with x minus 1. And x minus 3 quantity squared just means x minus 3 times x minus 3. So I'm going to FOIL that out. So I get x squared minus 3x minus 3x, negative 3 times negative 3 is positive 9. So now I'm left with x minus 1 is equal to x squared minus 3x, x minus 1 is equal to x squared minus 3x plus 9. So let's group these together, combine like terms, and I get x minus 1 is equal to x squared minus 6x plus 9. Now then, I'm going to get everything on one side. I'm going to move everything to the right side since that x squared is already on the right side. So now that I'm going to minus 1x from both sides, and I'm going to add 1 on both sides. Remember, if there's no number in front of the x, no coefficient, then it's automatically 1. So that cancels out. And now I'm left with 0 equals x squared. Negative 6x minus 1x is negative 7x. And positive 9 plus 1 is positive 10. Now, what two numbers multiply to positive 10 and add to negative 7? Right, so I'm going to factor this. Those two numbers are positive 5 and negative 5 and negative 2. So that becomes x minus 5 times x minus 2, or if you did x minus 2 times x minus 5, awesome. And now I'm going to split this up using the zero product principle. If I have a multiplication problem and the answer is 0, then we have to account for both factors resulting in a 0. So x minus 5 equals 0, or x minus 2 equals 0. And let's do some algebra. We're going to add 5 to both sides of the left equation. Cancels out, cancels out. So I'm left with x equals 5 or x equals 2. So now I'm just going to check my work and plug it back into the original equation. The radical x minus 1 is equal to x minus 3. And I'm going to repeat that for both. So now let's plug them in. So now I've got x equals 5. 5 minus 1 is 4, so the square root of 4. 5 minus 3 is 2. The square root of 4 is 2, because we're counting the positive square root, so that works. I didn't mean to check mark through the 3, but needless to say, x equals 5 is one of our solutions. Hopefully x equals 2 is as well. So now let's plug this in. 2 minus 1 in the square root is going to be square root of 1. And 2 minus 3 is negative 1. If I plug in the square root of 1 in the calculator, it's only going to count the positive root. It would need to indicate a negative root on the outside. So that's going to be positive 1 equals negative 1. That is a false statement. So x equals 2, even though you did everything correctly, is a bogus solution. So the only solution that does count is x equals 5. Okay? The square root of x plus 7 minus 5 is equal to x. So this is different from most. I've seen students in the past try to square both sides right now. My recommendation would be to get the radical isolated before you do any squaring, because it's much easier to cancel out a radical when all the layers, all the fluff is out of that side of the equation. So let's just do that. I'm going to repeat the problem. Radical x plus 7 minus 5 is equal to x. I'm going to add 5 on both sides. So now the square root of x plus 7 is equal to x plus 5. Now I'm in business, so I'm going to square both sides. The square cancels out with the radical, leaves me with x plus 7 is equal to x plus 5 times x plus 5. So x plus 7 is on the left side, so I'm going to FOIL this out. X times x is x squared. X times 5 is positive 5x. Positive 5 times x is positive 5x. And finally, 5 times 5 is positive 25. I'm going to combine the like terms over here and get x plus 7 is equal to x squared plus 10x plus 25. Now, I want to get everything on one side. I have a preference in this case to move everything to the right side since that x squared is already there. So let's just do that. Let me just get my green so it's not so confusing. So let me just rewrite the problem. X plus 7 is equal to x squared plus 10x plus 25. So I'm going to subtract 1x from both sides and subtract 7 from both sides to get the left side to become 0 and the right side to be a quadratic trinomial. Now then, x minus 1x cancels out, positive 7 minus 7 cancels out, and now 0 is equal to x squared. Positive 10x minus 1x is positive 9x still. And then positive 25 minus 7 is, that'd be positive 18. Now, well, thank goodness I have a positive combination. What two numbers multiply to positive 18 and add to 9? Two numbers that multiply to 18 and add to 9. Well, it's a positive combination, so it can factor into x plus 3 times x plus 6. So now we're going to use the zero product principle. Since I have a multiplication problem, the answer is 0. So if I have factor 1 times factor 2 equals 0, that means that one of the factors needs to be 0 itself. Now, I'm going to split this up into two cases, either x plus 3 equals 0 or x plus 6 equals 0. Now, if I subtract 6 from both sides, x is equal to negative 6. If I subtract 3 from both sides, that means that x equals negative 3. Well, hopefully these two are going to be my solutions, otherwise I'm crossing them out. So now, because the direction said so, I'm going to plug in our solutions into our variable x. The square root of x plus 7 minus 5 is equal to x. The square root of x plus 7 minus 5 is equal to x. So let's start with the left side. So I'm going to plug in x equals negative 3 into my equation. The square root of, negative 3 plus 7 is going to be positive 4. So now I've got the square root of 4 minus 5, which is, now we've got 2 minus 5 is equal to negative 3. 2 minus 5 is, in fact, negative 3. The left and the right agree. Notice that, I know that negatives make you uncomfortable with the radicals, but notice that the left side is literally the square root of 4 minus 5. So that's 2 minus 5. That's why we can get a negative on both sides. Now, if I look over here, I'm going to plug in x equals negative 6, and I get the square root of negative 6 plus 7, so that's the square root of 1, minus 5 is equal to negative 6. Now I move on, negative 6 plus 7 is 1, the square root of 1 is 1. 1 minus 5 is negative 6, but we actually do 1 minus 5 and we get negative 4 equals negative 6. No, dude. That's false. So what that tells me is that even though we did everything right, it is true, 6 and 3 multiply to 18 and add to 9. We did the zero product principle, but all this does was show that x equals negative 3 is the rightful solution, not x equals negative 6. So the only solution to this equation is x equals negative 3, because x equals negative 6 is extraneous, or as my 11th grade teacher used to say, bogus. Okay. 2 more problems. The square root of 5x minus 1 plus 3 is equal to x. See if you can do this problem independently. Okay. So first things first, I don't like this radical plus 3. If I'm going to undo the radical, I need it isolated. So what I'm going to do is rewrite the problem. Ooh, I don't want green, I want black. I want black and black, AC/DC. I want radical 5x minus 1 plus 3 is equal to x. And now I'm going to subtract 3 from both sides. And now the square root of 5x minus 1 is equal to x minus 3. And I'm going to square both sides to undo the layer of that radical. And I get 5x minus 1 is equal to x minus 3 quantity squared. And now if I FOIL this out, I get x squared minus 3x minus 3x plus 9. So that leaves me with 5x minus 1 is equal to x squared. Combine these like terms, I get minus 6x plus 9. Okay, so now, I don't like the fact that there's x's on the left and x's on the right, so I'm going to move everything to the right side. Since that x squared's already there, I'm going to subtract, sorry, let me just make this a little bit clearer. I'm going to subtract 5x from both sides, and I'm going to add 1 to both sides. The power of algebra. So that cancels out, and now that leaves me with 0 is equal to x squared. Negative 6x minus 5x becomes negative 11x. Positive 9 plus 1 is positive 10. Now, back to factoring quadratic trinomials, what two numbers multiply to positive 10 add to negative 11? So it has to be a negative-negative combination. Well, if you did the table, it was your first try. X minus 1, x minus 10. Negative 1 times negative 10 is positive 10. Negative 1 plus negative 10 is negative 11. So now I'm going to split this into two cases. Either x minus 1 equals 0 or x minus 10 is equal to 0. Now, solve for x. I'm going to add 1 on both sides and get x equals 1, hopefully. That's a solution. And then x minus 10 equals 0. I'm going to add 10 on both sides and get x equals positive 10. And hopefully that's a solution. But the directions will say solve for any extraneous solutions. So let's plug it back in. So I've got the square root of, sorry about that blue, there we go. The original problem stated 5 times x minus 1 plus 3 is equal to x. And I'm going to do that for the other side as well. 5 times x minus 1, all that in the radical, plus 3 is equal to x. So I'm going to plug in x equals 1 and x equals 10, and we'll check for the truth separately. 5 times 1, 5 times 1 is 5 minus 1. So the square root of 4 plus 3, right, is equal to 1. So we've got the square root of 4 is 2 plus 3 equals 1. 2 plus 3 is 5. I'm not digging this. I am not digging this. So what does that tell me? I did everything right. I followed all the rules, and x equals 1 should be a solution, but I checked my work and it's not. So therefore, x equals 1 is already a bogus solution. Did everything right, checked it, doesn't work. Let's try x equals 10 now. Well, 5 times 10 is 50. 50 minus 1 in the radical, plus 3 should equal 10. So 50 minus 1 is 49. So radical 49 plus 3 should equal 10. Radical 49 is 7. 7 plus 3 is 10. So 10 is equal to 10. Therefore, the only true solution, the true rightful heir, is x equals 10. Boo. Boo this one. Boo. Yay. Yay. X equals 10. Okay. One last problem, and then we'll call it a day. Nothing fancy here. The square root of 3x plus 7 minus x plus 1 is equal to 0. if you want to do this one independently, pause the video and see if you can. Okay, well, two things. I haven't seen this before. I haven't seen it all becoming 0. I would get everything that's not a radical on the other side. Just dust it off. I want radical 3x plus 7 isolated. So I'm going to get radical 3x plus 7 minus 1x plus 1 is equal to 0. Although I don't really need that 1x, but you know what? So I'm going to add 1x to both sides to cancel it out. And I'm going to subtract 1 on both sides and cancel it out, leaving me with the square root of 3x plus 7. I guess I didn't really need that 1x because it's just x minus 1, and I'm going to square both sides. Okay. So now the square and the square root cancel each other out, leaving me with just 3x plus 7 is equal to x minus 1 quantity squared. Let's FOIL this out, shall we? X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x, again, is negative 1x. And negative 1 times negative 1 is positive 1. So let's combine some like terms. Negative 1x and negative 1x combine to form x squared minus 2x plus 1. So then I get 3x plus 7 is equal to x squared minus 2x plus 1. All right, so now I'm going to get everything that is not part of the x squared trinomial on one side. I'm going to subtract 3x plus 7 on both sides. So what this does is this cancels out, leaving me with 0 is equal to x squared minus 5x. 1 minus 7 is negative 6. Ooh, this is a different case. So now we've got x squared minus 5x minus 6. What two numbers multiply to negative 6 but add to negative 5? So if you need the visual on the side, I'll happily oblige. Well, if it multiplies to make a negative, I'm going to cover up this right column right here, then we have no choice but to say it's a positive-negative combination. Well, now it's a positive-negative combination, but that tells me that the negative has to be stronger than the positive. Well, so that means a weak positive and a strong negative, a small negative and a small positive and a big negative. So let's try the obvious case, 1 and negative 6. 1 times negative 6 is negative 6, but 1 plus negative 6 is negative 5. Who would have thought it worked on the first try? We win. So this winning combination needs to be positive 1, negative 6. I'm going to factor this into x plus 1 times x minus 6. And now that I've factored it, the product is 0. I'm going to use the zero product principle to split this into two cases. Now I've got x plus 1 equals 0, or x plus 6 equals 0. X minus 6 equals 0, my bad. So I've got x plus 1 equals 0. I'm going to solve for x by subtracting 1 on both sides. X equals negative 1, hopefully. And x minus 6 equals 0, so I'm going to add 6 on both sides. X should equal positive 6, hopefully. Only one way to find out, we got to check for any bogus solutions. So I'm going to plug in the original equation, radical 3x plus 7 minus x plus 1. Oops, I meant to put blanks in there, but now I don't have to scroll up. So radical 3 blank plus 7 minus blank plus 1. And since the whole thing is equal to 0, I'm just going to rewrite them side by side. So now I'm going to plug in x equals -1 on the left side of the equation. And let's do them piece by piece. So now I've got 3 times -1, or -3. Let me improve the focus of this camera. Sorry about that. There we go. Radical -3 plus 7. Double negative right there. Plus 1. Plus 1. Huh. And that's going to be the square root of 4. Plus 1 plus 1. Remember, the whole thing is equal to 0. So now I've got 2 plus 1 plus 1 is equal to 0. 4 equals 0? I don't think so, man. So what does this tell me? X equals -1 is a bogus solution. Now, let's plug in x equals +6. So now I've got 3 times 6, which is 18. So radical 18 plus 7 minus 6 plus 1 should be equal to 0. 18 plus 7 is 25. The square root of 25 is 5. 5 minus 6 plus 1 should be equal to 0. 5 minus 6 is -1. -1 plus 1 is 0. 0 equals 0. Therefore, the only true solution to this whole thing is x equals 6. Have a great day.